All right, let me get a full screen up and running. So test day. Got the test in front of me. Here's the first page. You can screenshot it. Is it upside down? No, that's good. So let's see. How's that? If I hold it still for a second, all right, give you a chance, maybe screenshot, and then you got the problems in front of you. I've got them on the board already. And this test is mostly filling in gaps from Algebra 1, introducing some Algebra 2 material and some pre-calculus material. And hopefully by the end of the semester, some students might even be doing some early derivatives. Picking those topics at kind of a fundamental level, and then we're branching off as much as possible so we can hopefully get as much learning as possible. First question is finding three coordinates. We've done it, certainly in the first 10 lesson sets, and maybe it's 9 lesson sets at this point, I'm not sure. But we've certainly been doing this for quite a while. And if I'm going to multiply some number by minus 2/3 and I get the pick, well, the first number I would pick is 0. I think that's self-explanatory here. I don't think I got to talk about that one. The next number I'd pick would be 3. Now I can do this multiplication in 2 parts. I can do minus 2 times 3, which is minus 6 over 3, or I can divide 3 by 3, drop it in, and multiply it by minus 2. Whichever way I do that, I get an answer of -2. One more time. Let's pick a 6. 3 goes into 6. 2 times -2. I could have done it that way. Or I could have done minus 2 times 6 is minus 12 divided by 3. I'm hoping you're seeing go small then big, rather than big then small. It's easier on the brain. All right. The only problem is, I'm looking at the multiples of 3. I'm hoping you're making that connection right now. But I'm not starting at 0 unless I put what number in here. Well, first thing I would do is make sure that everybody realizes that I prefer minus 2/3 x minus 4 plus 5. To write that, this is a left to right configuration for the brain. Whereas I got to drop a number in, I got to compute, and then I got to move over to the left side. It's easier to see if you put a 4 in, you get a 5 out because I've created this situation. It's easier to see that. And I hope you can see, and because we talked about it enough, that 3 is really going to dictate the change in the x. 7, 10, etc. So if I put 7 in, I hope you can see, we've created this next situation. And the math is easy to do. 3 goes into 3. 7 minus 4 is 3. 3 into 3. Okay, so that's your x side. That's your inputs. Your outputs. Well, your outputs, over here, this output is a 5. This output, if I add 5 to that, let's get my eraser here, but if I add 5 to that, minus 2 plus 5 is 3. And if I add 5 to this, minus 4 plus 5 is 1. Well, geez, I hope you're looking for patterns. Sure looks like that's the case. That's dictating change in the y. Right? And that's what slope is. Change in the x over change in the y. Change in the y over change in the x. It's right there. All right, so something to know. Now, I've asked you to sketch this. And the reason I put this problem here is there's no excuse not to be able to sketch a line for everybody who's getting this right. And most everyone in the class is. Occasional careless error from me and everyone else. But everybody understands this. If you understand this, I just don't understand how anyone cannot put down 4, 5, and right here, there's 4, 5. And if we put 7, 3, well, 7 is maybe here. 3 might be about there. I'm right about here. And 10, 1, another 3 units, same jump, 1 unit. And what are those dots doing? They're lining up. And we could continue doing that forever or thinking backwards forever. And this is all the solutions to this equation because this is an equation. And I can't list all the solutions in a table. That's all I do in life. But I can put it on the board in 2 seconds and we can get a feeling for change. As x gets bigger, y gets smaller at a 2 to 3 ratio. All right. If you can mental math that and just write your answer, which is 8/3 x minus 16, so I gotta say plus 16 to get that multiplication by 0 plus 80. Go ahead and just write it. That's what's perpendicular to this, passing through negative 1680. But if you haven't made the connection yet that the answer's staring at you, then you got to do the math. 8y equals minus 3x plus 23, and y is equal to minus 3/8. I stopped there. That is the slope. Okay, and what's perpendicular reciprocal? Perpendicular reciprocal is 8/3. All right, so let's just draw that real quick. Down 3/8 gives us a line that looks something like that. Perpendicular is something that looks like that, and that's over 3 and up 8. Okay, so down 3/8 over 3 up 8 makes that perpendicular. So that's question 3 on this test. So my equation, again, if I want to pass through negative 16, I write x plus 16 because that makes 0, and multiplying by 0 is really fun and easy. And if I put negative 16 in, I want a y value of 80. So why don't I put my y's there? My x values come in from this direction and they give me answers. But now I want the perpendicular, and the perpendicular happens to be 8/3. Okay, so that's that one. G of x equals 2x minus 7. Okay, what's in the parentheses? X values. And I just gave you one. So what do? You use it. 2 times 5/9 minus 7. And if you can do this in your head, go ahead. So that's equal to, oh, I guess I got to make some room here. So I'm erasing the original problem, but it's right here. So 10/9 means I need 9ths over here, which is minus 63/9. 9 times 7, 63, and 10 minus 63 is minus 53/9. And if you can do the next problem, I shouldn't have erased it, but I have it right here. That's 2x minus 7. That's another name for g of x. Oh, another name for g of x is 2x minus 7. Oh, so I'm Mr. V sometimes in class, and sometimes I'm Jim. Times have changed. Another name for g of x is 2x minus 7. Then why don't I give g of x the other name? 2x minus 7. Okay, so 2x minus 7 is a linear function, 0, -7, the y-intercept. I'm going up at a 2-to-1 rate, and I want to know when I hit 3/4. Well, it sure looks like it's an x value maybe around 3 or 4. I don't know. Well, I do actually. We could go over 2-to-1 to count it. But how do you solve this? Get rid of the fraction. 8x minus 28, multiply everything by 4. Okay, so you know you got division by 8 here, right? You know you're adding 28, so you could go right to the chase. Then x is what? I know I'm going to divide by 8. I'm bringing minus 20. Geez, I think I can skip a step there. And believe me, you can keep skipping steps in my class. Much as you want, as long as you get it right. Okay, so now let's move this table a little closer. Oh my God, I just went out of full screen. Oh boy. I ain't got to get my cart. It's upstairs. Got to move it. So we're on this problem and we can see it. All right, so f minus 1 of x, that means the inverse of that. The inverse of that. But this is a function based on x values. So I got to figure out how to turn let's put a 2 in. 2 gets me 11. I got to figure out how to get 11 back to 2. That's kind of what we're after. Now, textbooks would say y equals 5x plus 1. Change the x's and the y's and solve for y. That's all good. Don't get me wrong. Nothing wrong with this. X minus 1 equals 5y. Then y equals x minus 1/5. I don't think you have to put an x and a y in here. I think that's basically the operations we use to solve an equation. So let's say that this thing equaled 100. Well, what's the first thing you would do? You'd subtract 1, and then you'd divide by 5. So feel free to do that. It doesn't work for every situation, but in these situations where you have an isolated x, it's fine to do. And that's my inverse. And now I check it. A 2 gets me 11 in the original function. Does an 11 minus 1 divided by 5 get me 2? Yes, I'll move on. 3x plus y, 2x plus 5y, 1 equals 9, 1 equals 19. Doesn't hurt to get a little feeling for right answers. So the standard form, that was problem number, well, I haven't done that one yet, but it's coming. So let's put a 0 in for x. You got a y-intercept of 9. That's now 9 units. Put a 0 in for y. You got 3. So that's looks to be close enough to give me a feel for what quadrant my intersection's in. 2x equals 19 at 9.5. If that's 3, 9.5 might be over here. Real rough estimate. And 5 goes into 19, a little less than 4 times. So a little less than 4. So I've got that. It looks like I've got an intersection in quadrant 1. So my x and my y should both be positive. Unless I made a careless error, and I make more and more all the time, because I'm trying to think about how I can explain this, and I lose track of the numbers. Just age, I'm afraid. So I'm going to get rid of the y column. I am going to multiply the top by the first equation by -5. And that's all I have to do. If I multiply that by -5, I get minus 15x minus 5y equals -45. And the second line is 2x plus 5y equals 19. Well, I got my answer here, right? Minus 15 plus 2 is minus 13. So I'm going to divide by minus 13 at some point. And if I set it equal to that side, well, I better do this out, because I like to change my divisions and have them non-negative. So right now I have minus 13x equals 20 from 45 is 45. So I believe that's minus 26. Okay. We can see our answer, x equals 2. As soon as we have x equals 2, we know that 6 plus y equals 9. We plug in 2 here because it's easy to do. And therefore, y is equal to 3. And so y is equal to 3. And does it look like that could be the coordinate 2, 3? Absolutely. Remember, that was an x value of 3. So I believe that 2, 3 works. If I really want to check it, I got to plug it in. So let's plug 2, 3 in, see if it works by a numerical process. Okay, so I guess I'm here. 3 times 2 is 6 plus 3 is 9. Check. 2 times 3 is 6 plus 3 times 5, 15. No, 2 times 2 is 4. Y was 3. So 15 and 4, 19. Yes. Looks good to me. Slope intercept. The only purpose really for this is to make sure everybody can multiply a fraction and add a fraction quickly and easily. Minus 2/7 x plus 10/7 minus 8 equals minus 2/7 x. 8 has to be expressed as a common denominator. So 7 times 8 is 56. So I have 10/7 minus 56/7. So my final answer, minus 2/7 x minus 46/7. That's the same equation as that. Next problem. We could do the graphical to find the intersection. 2/5 x minus 1. We'll do that quickly over here. Minus 1 is the y-intercept. Over 5 down 2 gives me a line there. Minus 2 is that y-intercept, and over 3 and up 2. Okay, so it looks like I have an x value that is fairly small and a y value that's negative and small in terms of magnitude. Okay, so I'm definitely in the 4th quadrant. Make sure you know your quadrants. That's quadrant 4. 1, 2, 3, and 4. So we're in quadrant 4. What is the issue here? The issue here is fractions, so get rid of them. Division by 3 and 5 can be gotten rid of by multiplying those numbers by 15. 1/5 and 1/3 times 15. 5 goes into 15, 3 times minus 2x minus 6x minus 15. 5 times 2x, 10x minus 30. I don't like dividing by negatives, so I'm going to move the 6 to this side, which means I'm going to get division by 6. And I'm going to move the 30 to this side, and that means I'm adding 30 to minus 15. So I like mental math. But you're not used to doing that, so bring the 6 over. bring the 30 over, do that in your head. And I can see 15 over 16 equals my x value. All right, hopefully I'm not making any careless errors. Now we're going to write the equation of a line through these 2 points. I want to measure vertical and horizontal change from a coordinate. And I want to measure the horizontal change from -2. So I write x plus 2. So if I put the number 3 in, 3 is 5 units from -2. Oh, 3 plus 2 is 5 units from -2. I'm measuring horizontal change from -2. Vertical change from 3. So if I put a 1 in, I get 3 units of horizontal change. So why don't we divide by 3 to make that the number 1? And how do I get from 3 to 11? I got to go up 8. How do we check to make sure this is right? On a test, you put the second coordinate in. Does a 1 get me an 11? 1 plus 2 is 3. The 3's cancel. 8 plus 3 is 11. You move on. Now, I don't do that with my answer keys because I'm writing too many tests, too many worksheets. So I'm just hoping I don't make a careless error. And then you go find them, and usually 2 or 3 on a 50 to 100 question test. Just got to live with it. So that's that one. Okay, now, standard form. I'm not giving any credit for graphing 2x plus 5y equals 40 if you manipulate it. There's no reason to manipulate it. Just find your x and y intercept. How do you find your x-intercept? Let x. How do you find your y-intercept? It's when x is 0. If I make x 0, it's like covering it up with my hand. And I get 5 into 40. This goes through 0, 8, little rotator cuff problem up here. Okay, and I know addition of 2 terms that add up to a constant. If the first one goes up, the second's got to go down. So let's find the x-intercept. Cover up that by letting y equal 0, and 20x goes into 40 twice. 2 gets me 0. That's all I want to see. If I see anything other than the y-intercept and the x-intercept, then you have not correctly graphed from the standard form perspective. And that's what I'm testing. So if somebody switches this to mx plus b, I'm sorry that you got drilled with that in your last class. X minus 1 over 2 minus x minus 3 over 5. Bingo, bango, bongo. It's in the earlier lesson sets. What's bingo? Cross product, 5x minus 5. Bongo, 2x minus 6. Now we can see the negative, negative, and otherwise we might not be able to, and in this case, 10. So what's my final answer? 5x minus 2x, 3x, minus 5 minus a minus 6, plus 1, all over 10. How do I check that? If it's a final exam and I have time, I'm going to plug in the number 3 here. What happens when I plug 3 in there? That's gone. What happens when I plug 3 in there? 3 minus 1 is 2. 2 divided by 2 is 1. A 3 gets me 1 in the original equation. Well, it's not an equation. The original calculation. If I'm saying this is the same, then a 3 has to get me 1. 3 times 3, 9, plus 1 is 10. 10 divided by 10, 1. I move on. All right, so you want to be able to see 49, 16. You want to be able to see the square root of 33 in your mind's eye. The only way you're going to see it in your mind's eye, well, I'm thinking that's your fault, Yasu. You said something about the mind's eye. I had to look it up on Google who Soren someone was. Yeah, but I learned something about that. So you want to have this picture. We're going to draw these in our quadrant system because we're headed towards trig within a week or so. No, we're headed towards trig right after I do this problem. So z is 7, x is 4. If that's 4 units right there, I'm going to say 7 units is about there. I'm going to say that's 7, that's 4, and I'm trying to find that. And I've got this. Then I got Pythagoras. I've got 49. I've got 16. I got to figure out that square area because the 2 are smaller squares add up to that. And I can see it's 33. And I didn't make a mistake. And so therefore, what is that side length? The square root of 33. All right, now what's that going to lead us to? It's going to lead us to an angle because I'm drawn in standard position. And I can see my sine of that angle. Root 33 over 7. Let me get rid of these areas. Go back to what we have now. We now have a triangle that has a width of 4, a height of root 33, which is a little less than 6, and I have 7. And the sine of that angle is that ratio. The cosine of that angle is that ratio. And the tangent of that angle is that ratio. Planting some seeds. All right, so can you do this problem in your head? Well, first thing I see is x squared times -2. I'm going to write -2x squared. I know binomial squaring. I know the shortcut to that. 4x doubled is 8x. 8x times -2 is -16x. And I know 4 squared 16 times -2 is -32 plus 6 is -26. But feel free to rewrite that as, well, hopefully you don't have to do this too much longer, but go ahead and FOIL it. And if you do, you're going to get x squared plus 8x plus 16. And then move the positive 6 to the end, because you always do the hardest part of this problem is squaring, then multiplication, then addition. And we go from hard to easy. So -2 times x squared is -2x squared, -2 times 8x is -16x, -2 times 16 is -32 plus 6. And yes, indeed, we got ourselves a nice little check. All right, what are we hoping to learn here? We're hoping to learn that a problem like that requires absolutely no effort to solve. X equals 5/3 or x equals -7/2. Let's just put 5/3 in for x. 3 times 5/3 minus 5 times 2 times 5/3 plus 7. You do the math here. Well, let's do the first parentheses. What happens to the 3's? Cancel. And 5 minus 5 is 0. And I do believe 0 times anything will arrive at 0 for an answer. Okay, so if you can write products, a lot of times you just take a little quick glance and you got a lot of information at your fingertips. So this was a parabola that went through -7/2, which is -3.5. And also 5/3, which is a little smaller in terms of magnitude. Boom, that's your parabola. What's the average? The average is minus b over 2a, which I'm not going to do now because I have to multiply that out. All right. I see a quadratic. I know I'm on the decreasing side, 0, 1, but you might not have known. So therefore, you got to find the x value that's most important. And I hope we're saying it enough each and every day that your brain just went to minus b over 2a. And from some of the lectures and talk, hopefully you know why. All right, so that's the most important x value in this problem. Minus b, 12 divided by 4 is 3. So that's 3. And yes, 0 is to the left of 3. That's a comma. Now we have to find the y value that goes with it. So we have an equation that finds y values if you know an x. I now know an x. I also know another x. If I plug 0 in, I hope everybody can see why, we get a value of 1. Now when I put 3 in, I get -36. So without looking, if I'm not getting positive 18, I'm wrong because of the 2 to 1 opposite relationship. And there's various reasons for that, and playlists in the quadratic talk about that. So this becomes -18 plus 1, which is -17. And I'll check that out real quick by moving 3 units to the left and squaring, going up 9. But -17 to 1 is up 18. And I think that differential divided by that one gets me 2. Okay, so I didn't make any mistakes. And I also now know what the roots are. The roots are hitting a height of 1. So I got to have an answer that's positive, but a little bit bigger than 0. And another one that is 3 units to the left, 3 units to the right, just a little bit bigger than 6, right? Because 6 gets you 1 because of the symmetry. Oh, I'm just a little less than 6 on this side. Excuse me. Am I right? Yes, that one's a little less than 6. This one's a little bit bigger than 0. And it turns out that those x values are measuring from 3 to the right side to get an answer, to the left side to get an answer. The square root of, how far is it from -17 to 0? 17 units. And the multiplication by what was it? 2. Well, those are your roots. Okay, so now what's the minimum value for this function? That's what I asked next. Let's move this desk this way. I've definitely got to bring my cart down the next time. So let's hope that you can see this. Yeah, so this is asking for the minimum value. Well, I come back to the graph and I look and I say, well, what's the smallest y value I have on the board? A little messy. So let's just doctor it up. I think the only thing, that's an x value, right? That's just a random number. It happens to be an important one, but that's the smallest y value. It's right there. So that's what I'm looking for an answer. I'm not looking for the coordinate. I'm looking for that number, right? If I said, what's the warmest temperature today? Well, okay, 3 o'clock, we hit the warmest temperature of 32 degrees here. Well, if I ask for, what's the warmest, I'm asking for a maximum temperature. I don't care what time it is. The maximum temperature today is 32 degrees. It's going to be. Actually, I think it's going to be raining and 40. Okay, so that's what that is. And now we come over here, 2 more problems. Basically did what we're hoping to do here. So I wrote that out. I'll write it out again perhaps. Maybe I shouldn't have erased that because I was thinking about how to explain this in the best possible manner. And that always changes with practice. So minus 5, 7. And that's another minimum, by the way, 7. X minus 5 squared plus 7. That gives us where we're going to measure from. And what are we measuring here? Squared change. Squared change. So if I go from -5 over to 1, that's a change of 6. That's what's in the parentheses. But I'm canceling squared change. So if I went over to the number 1 and squared it, I've got 36 plus 7. I don't think that's 11. I don't think that differential of 36 units is taking me to 11, which is really 7 to 11, only 4 units of change. Okay, so I got to get rid of the differential that doesn't work, and I got to bring in the one that does. And that was, well, here, 4. I don't care if you reduce the fraction today. Obviously, that's 1/9 of what should have happened. And that's that function. So I'll give you another one to try here. Probably should have been doing that right along, but trying to keep the videos down a little bit. So let's see, how about -2, 9? All the way over here, let's stay on the right, to 3, 100. You pause the video, and I hope you wrote the following. That's that function. These x values are going to get those y values. These x values are going to get those y values. Now, y is 9 a minimum. Well, when I put -2 in, I get 0 squared. That's the smallest number. The smallest number squared, the smallest number you put into the squaring process to get a minimum is 0. I don't care if you put a positive or a negative in here and square it, you're getting a positive result. So therefore, any other number I plug in besides -2, things are going up. No, we can see that, whichever one you were doing. I guess that one. This was the new one. Well, I hope we can see that. All right. Last problem. Now, a lot of my worksheets are based on problems students have trouble with in my calculus classes. And people could not do this integration. If they rewrote this into a more familiar form, nobody had any trouble with the integration, right? But folks had a real hard time answering x plus 3 times what equals x squared plus 8x minus 3. Which in Algebra 1 is usually expressed as a long division problem, right? People wonder why they do it. Yeah, it's just an extension of the foiling process. So x times what gets you x squared? X. So how many times is x going to x squared? X times x is x squared. Change the sign and add, that column goes. And as columns disappear, and you know they disappear, you even stop writing that, and then you head to synthetic division. But I'm not teaching that. So Now I have x squared plus 3x. Well, I want x squared plus 8x. I got to get another 5x in here. I got a marker. There. I just put 5x in there. Now I got the first two terms. Of course, if I multiply 3 times 5, I've got 15. And I'm trying to get to -3. Well, 15 and -3 means I got to go down 18. So I'll put it outside the parentheses for now. It's outside the parentheses for the moment. Now, what's the critical number here? Well, the critical number is -3 because it's easy to work with. That's one reason. So -3 plus 3 is 0. 0 times anything is 0. I get -18. Well, if this calculation is equal to that, then for all numbers, the same correlation has to exist. So if I put a -3 in here, it better come out as -18, or I got to go back and find my careless error. So -3 squared is 9. -3 times 8 is -24. -3. Well, that's 9 minus 27. And that is, if I'm not mistaken, -18. Now, if I were going to do the long division, I got to continue this process. And all long division is keeping track of what your brain's doing in the mental math arena. So x times x, x squared, change the sign and add. X times 3 is 3x. That's a positive 3x. I change the sign and add. I like to add. It's easier than subtracting. So I bring in the negative earlier than putting it in parentheses and subtracting. So 8x minus 3x, well, there's your 5x. We knew we needed 5x, right? We did it earlier. All right, so now x goes into 5x. There's your 5. 5 times x is 5x. I like to change the sign and add. 5 times 3, well, let's bring down the -3 here. 5 times 3 is 15. I like to change the sign and add. And there's our -18. So this is just a mechanism for keeping track of what we need to have happen. Now, the nicer way to write this is as follows. Bringing the -18 into the parentheses. But I don't want to have it multiplied times x plus 3 because then it's not going to work too well with the number 5. So I divide by x plus 3. Well, let's do that out. Let's see what happens. Let's do the foiling first. X plus 3 times x plus 5. X squared plus 8x plus 15. Okay, I've done this times this. I've done it, so I'm going to get rid of it. Well, x plus 3 times -18 divided by x. I meant to say plus 3 there. I hope that's yes, that's what I started with, I guess. Yeah, it's up here. Well, what's going to happen? It's going to cancel, and we're going to get -18. And when I get -18, well, that's what I need to multiply by to get x squared plus 8x minus 3. All right, so that's another hurried video, but you have the ability to replay things. And, I have to do it quickly because this is a 65 question test. And the next page is a little harder. The one after that, a little further up the ladder. And I like to look at every problem, have my students look at every problem every day. And generally speaking, if you do each problem every day, just look at it, follow things, then you're probably going to get most of those problems down in 4 days. And if you don't believe me, try it. All right, so don't try to learn this in 1 day. If there's a new problem up there, just take it in and then replay or do the next lesson set. It's nice if you can do it in consecutive days, but usually 4 days in a row, 2 minutes a day, looking at a problem, brain starts to process things, sees it a little bit more each day, and then the lights go on. And then you just have to keep working with it every day, so it's working knowledge. All right, I'm rambling, but I got to get this up and got to do two more pages of a video. Okay, have a good day.